Meet Paul and his wife Kate. It's an exciting time for Paul and Kate because Kate is pregnant. It's then that Paul remembers. Kate's father is colourblind. What's going to happen to baby? Will she be colourblind too? Kate's not colourblind, but she gets a bit of Kate's father's DNA, doesn't she? Which DNA is going to win out? So Kate and Paul approach their midwife to find out the chances that baby will receive her grandfather's colourblindness.
Inherited colour vision deficiency, or colour blindness, is a condition which is inherited from your parents. It is therefore hereditary. Red-green colour blindness is found on the X chromosome. Men have one X chromosome and one Y chromosome. Women have two X chromosomes. These two chromosomes are the ones responsible for determining the sex. Chromosomes contain a whole bunch of instructions that determine the development of cells, tissues, and organs. If you are colourblind, it means the instructions are a bit messed up. Essentially, your cone cells don't develop properly. Perhaps some are missing, or perhaps the pathway between your cone cells and the brain hasn't developed. Just remember that the faulty colour blindness gene is only found on the X chromosome. So what does that mean? Well, this means a baby boy would only need to inherit one faulty X chromosome to be colourblind. A baby girl would need two faulty X chromosomes to be colourblind. If a baby girl only got one faulty X chromosome, then she would be a carrier, but she wouldn't actually be colourblind. So where does that leave Paul? Well, there's some good news, because a baby girl will not get a faulty X chromosome from him. This is because he isn't colourblind and a man cannot be a carrier, so she is only in danger of receiving one possible faulty chromosome. So what if Paul has a son then? Well, since Kate's father is colourblind, she would have received one faulty X chromosome from him, so Kate will be a carrier. We also know she only has one faulty X chromosome, otherwise she would be colourblind. This means there is a possibility that a son could be colourblind. So with that in mind, let's look at the chances laid out on a neat table. You will see that since Kate is a carrier of the colourblindness gene, there is a 50% chance that a son would be colourblind. There is a 0% chance that a daughter will be colourblind, but there is a 50% chance that she will be a carrier.
The midwife has certainly put Paul's mind at rest. That is, until he thinks about the early morning wake-up calls.